This technology that we call MegaProjector is essentially extremely high frame rate and very fast display technology. It consists of two chips essentially. So one chip is a micro LED array that we fabricate in-house here at the University of Strathclyde, and the other side is an electronic driver array which has been designed by our collaborators in QuantIC from the University of Edinburgh. Micro LED array technology is an emerging technology for displays, things like virtual reality displays, augmented reality displays, even televisions, because these pixels are 10 to 100 times smaller than a normal LED that you would buy from the shop. We've been looking at other applications for micro LEDs because we found some interesting behaviours as you make the LED emitter sizes very, very small. One is that you can switch them on and off incredibly fast. That's why we've been looking at using them for optical communications, because you can get extremely high data rates wirelessly through an LED. So essentially you can imagine a very high speed data being transmitted by a light bulb, which can provide extra capacity to supplement Wi-Fi networks and ease congestion on Wi-Fi networks.
I'm working on imaging applications on a technique called single pixel imaging, where I use our MegaProjector chip to do really fast imaging with only one pixel in my camera. The area where it's more useful is if you want to image using non-visible light. So instead of using red, green, blue, we're talking about maybe trying to do imaging in ultraviolet. Ultraviolet cameras are really expensive, so using a one detector camera would be really beneficial.
We tended to look very, very broadly at lots of different applications for the micro LEDs, and MegaProjector is kind of the flagship device in the sense of it's our most capable device with the most functionality.
A lot of other people who've done high-speed stuff, there's limitations on what you can display on each pixel, whereas with MegaProjector we can have complete control of what goes on every single pixel. There's numerous technologies, but one of the most important ones is a digital micromirror device, DMD. These are how people have done these patterns in the past. But the problem with the DMD is the fastest it can go is 32,000 frames per second. With MegaProjector, we can do 400,000 frames per second. So we're going over 10 times faster than competing technology. And likewise, if we're going to do ranging, 3D imaging, potentially we could do it significantly faster than people who are using DMDs to do it.
I've always been drawn towards research that people will use in their day-to-day lives. You might have a micro LED device at some point in the future on your television display, hidden inside your light fixture to provide you wireless data. If you go to the doctor and get a blood sample, the test might use a micro LED array to analyse the sample. What appeals to me is to feel like you're working on something that at some point in the future might just become part of the everyday fabric of people's lives. QuantIC have been very, very good, helping us engage with commercial partners and funding proposals and things like that, allowing me to polish my skill at speaking to a much wider audience. It can be quite difficult to break out of thinking and talking about things in a particular way, and they're very good at being able to break down the communication barrier between researchers and the external partners.